The idea in this is to start with one side and make it look exactly like the other side. So let's start with the left side. Sine 2x. Well, sine 2x is the same as sine of x plus x, which is sine x cos x plus cos x sine x, which is the same as sine x cos x plus, switching these around, sine x cos x. And then you say to yourself, 1 sine x cos x plus 1 sine x cos x is equal to 2 sine x cos x. It's the right side. I'm going to use the same strategy, left side. Cosine 2x is equal to cosine x plus x, which is the same as cosine x minus sine x sine x. But cosine x times cosine x is cosine squared x, and sine x times sine x is sine squared x, which is the right side. Alright, well, we know that cosine 2x is equal to cosine squared x minus sine squared x. This is from our previous identity. Now that we know it, we can't unknow it, so we can use it. So we can say this is the same as cosine squared x minus, and instead of sine squared x, I'm going to replace it with 1 minus cosine squared x. Now I can do that. I'm just going to move to the side here, because I know that sine squared x plus cosine squared x is equal to 1. So I can move the cosine squared here, and that'll tell me that sine squared x is equal to 1 minus cosine squared x. That's where I got that from. Alright, that's equal to cosine squared x minus 1 plus cosine squared x. And when you add cosine squared x and cosine squared x, you add them up, that's going to give you 2 cosine squared x minus 1, which is, you guessed it, the right side. Well, we know from the previous example that cosine 2x is equal to 2 cosine squared x minus 1. And what I'm going to do is, I'm going to write 2, and instead of cosine squared x, since sine squared x plus cosine squared x is equal to 1, cosine squared x by itself is equal to 1 minus sine squared x. So I'm going to put that into here. So I replace cos squared x with 1 minus sine squared x. This is going to give me 2 minus 2 sine squared x minus 1. 2 minus 1 is 1, minus 2 sine squared x, which predictably is the right side. Remember that tan x is the same as sine x over cos x, and tan 2x is the same as sine 2x over cos 2x. So remember that sine 2x is equal to 2 sine x cos x, and cos 2x is equal to cos squared x minus sine squared x. Now, the left side, tan 2x is equal to sine 2x over cos 2x. This is equal to 2 sine x cos x over cos squared x minus sine squared x. Now, what I'm going to do is multiply top and bottom by the same thing. But before I do that, I'm going to say 2 sine x cos x. I'm going to multiply by 1 over cos squared x. But if I do that to the top, I also have to do that to the bottom. Because by multiplying top and bottom, essentially I'm not changing the fraction. Now when you multiply that out, what happens is you've got 2 sine x cos x over cos squared x, which is really just cos x times cos x. On the bottom, cos squared x times 1 over cos squared x will give us cos squared x over cos squared x, minus sine squared x times 1 over cosine squared x will give us sine squared x over cosine squared x. Cosine x and cosine x cancel out. 2 sine x over cos x is 2 tan x. Cosine squared x over cosine squared x is 1. Sine squared x over cosine squared x is tan squared x. So I start with my left side. Cosecant 2x is equal to 1 over sine 2x, which is equal to 1 over 2 sine x cos x. I'm going to multiply the top by 1 over sine x. I'm going to multiply the bottom by 1 over sine x. So that's going to give me 1 times 1 over sine x. Well, 1 over sine x is just cosecant x. On the bottom, I've got 2 sine x cosine x over sine x. So these two will cancel, which leaves me with cosecant x over 2 cosine x, which is the right side. Now for this particular one, I'm going to actually start with this side. So I'm going to start with the right side. The right side is equal to sine x cosine x multiplied by tan x, which is sine x over cos x, minus cotan x, which is cosine x over sine x. I'm then going to carefully multiply these two out. So when I multiply these two out, I'm going to get sine squared x cosine x over cosine x minus these two multiplied to give me sine x cosine squared x over sine x. Gone, gone. It's going to give me sine squared x minus cosine squared x. Now this is one of those situations where you have to keep an eye on the other side. You want it to look like 1 minus 2 cosine squared x. Somehow the sine squared's got to go away and you need another one of these. So the best thing to do is replace sine squared with 1 minus cosine squared x minus cosine squared x. And then these two combine to give us 1 minus 2 cosine squared x, which is of course our left side. So let's start with the left side. The left side is equal to 1 minus sine squared x over cos x. Now 1 minus sine squared is the same as cosine squared x, and then you have cosine x in the bottom. This is going to give us cosine x over 1. I'm going to multiply that entire fraction by 1. Instead of 1, I'm going to use 2 sine x over 2 sine x. This is 1. But when I multiply the top, that'll give me 2 sine x cos x, and on the bottom it'll give me 2 sine x. But 2 sine x cos x is just fancy talk for sine 2x. I'm going to start with the left side. Cosecant squared x is basically 1 over sine squared x minus 1, but I'm going to write 1 as sine squared x over sine squared x. On the bottom I have cosecant squared x, which is 1 over sine squared x. I'm going to take this and combine it into one fraction. I've already got my common denominator. My top's going to look like this. And I'm going to multiply by this fraction flipped over. I cancel them out. Which is my right side. I'm going to start with my right side. My right side is equal to cosine x minus y, so that's cosine x cosine y plus sine x sine y minus cosine x cosine y minus sine x sine y. I'm going to take everything out. I'm going to be really careful with my signs. Cosine x, cosine y, plus sine x, sine y, minus cosine x, cosine y, plus sine x, sine y. Cosine x, cosine y, minus cosine x, minus cosine y, oh so sad, say bye-bye. Sine x, sine y, sine x, sine y, 2 sine x, sine y, which looks like your left side. Left side. This looks like cosine squared x squared minus sine squared x squared, which I can factor out as a difference of squares. Cosine squared x minus sine squared x, cosine squared x plus sine squared x. But cosine squared x plus sine squared x is equal to 1. So I'm left with this. And then I say to myself, self, that looks like cosine 2x. Say word. Word.